This demonstration is going to show you how to create a grouped frequency distribution. The steps for this procedure begin on page 2 of the supplemental information handout. For this example, you can see I have a set of 30 IQ scores. The first step in creating a group frequency distribution is to choose the number of intervals. This choice is somewhat arbitrary, but for this example I'm going to choose 8 intervals, so k equals 8. The next step is to compute the range. To compute the range, I need the highest score, which is 138, and from that I need to subtract the lowest score, which is 82. And with that I get a range of 56. Next, I need to compute the interval width, and this is simply the range divided by the number of intervals. So this h is going to equal 56 divided by 8, which equals 7. Now I need to compute the lower bound of my first interval, or M0. So M0 is simply going to be the minimum score, which is 82, minus the range, 56, divided by 1000. And that's going to equal 81.944. The reason for subtracting off that 56 divided by 1000 is just to make sure that your lowest score is actually counted in one of the intervals. Next, I need to compute the upper bound. So this is going to be actually the upper bound of my highest interval. So this is going to be the upper bound for M of 7. And I'm calling this M7 because I'm numbering my intervals beginning at 0. So my 8 intervals are going to be 0, 1, 2, 3, 4, 5, 6, and 7. So M7, that is going to be the highest score, which is 138, plus 56 divided by 1000. And that's going to equal 138.056. And again, the only purpose for adding that small number, that 56 divided by 1000, is to make sure that my highest number is actually counted in an interval. Now that I've created the lowest boundary for my first interval and the upper boundary for the last interval, I'm going to go ahead and create the rest of the intervals. To do this, I'm going to list them in reverse order. So here I'm going to start with the last interval. So it's going to be 7, then 6, alright, and you can see again that I've counted my intervals from 0 to 7. Since I already know M0, I can go ahead and write that, and that's going to be 81.944. So the second column, this is actually going to be my lower intervals, and I'm going to have a third column that represents the upper intervals. To get the upper boundary of my first interval, I can simply just add the interval width 7 to the 81.944, and with that I'm going to get 88.944. And since this is the upper boundary of my first interval, it's also the lower bound of my next interval. So I'm going to list 88.944 here. And I can simply continue in this fashion. I'm just going to add 7 to 88.944, and I'm going to get 95.944. Carry that up to the next interval, 95.944, and then add 7 more, 102.944. Add 7 again, and move it up. Now for this upper boundary of my last interval, remember I've already computed that, so I don't need to add 7 here. I can just take the value I computed previously, which was 138.056. And so there are the upper and lower boundaries of the intervals. But you may be asking yourself, okay, what if I get a value of 88.944? Which interval is that value counted? Well, we're going to do this in a way that it's upper inclusive. So for instance, I'm going to put a left parentheses on the left-hand side and a square bracket on the right-hand side. The square bracket means that if I get a value of 88.944, I'm going to include it in the interval where that square bracket appears. So in other words, that bracket means it's inclusive of the value it's next to. So I'll just continue on like this to mark off my intervals. So if you get a number that's actually on the boundary, you include it in the interval that has the square bracket next to that value. Now that you have the intervals, you simply need to go back to the data and start tabulating where each data point falls. I've already done that, so I'm not going to demonstrate that here, but I'm going to add another column. And this column is for the frequency. Hang on a sec. I'm still getting used to writing on an iPad. So that's supposed to say freak. And if I do that, then what I end up with, I have 5 values in that first interval, 4 in the next interval, and 7, 5, 2, 2, 1, and 4. To compute the relative frequency, or the proportion of participants in each interval, I simply divide the frequency by the sample size. Alright, so this relative frequency is going to be 0.13 for this top interval, and these are repeating decimals, so I'm just going to round them to 2 decimal places. It's going to be 0.03, 0.07, 0.07, 0.17, 0.23, 0.13, and 0.17. And those relative frequency values should add up to 1. If they're slightly different from 1, it's simply because of the rounding here. Now, I can also compute the cumulative frequency. So this next column is going to be the cumulative frequency. And to compute that, I start at the bottom. So I'm going to write 5, and then to 5 I'm going to add 4 to get 9. And then I'm going to continue to each value of the cumulative frequency I get, I just add the frequency of the next higher interval. And with that I get 16, 21, 23, 25, 26, and 30. And you can compute the cumulative proportion in really the same way. You divide the cumulative frequency by the sample size. So the cumulative proportions are going to be 0.17, 0.3, 0.53, 0.7, 0.77, 0.83, 0.87, and of course it should be 1 by the time you get to the top interval. And so there you have your grouped frequency distribution. What you'll see in the next demonstration is how to use this information to compute percentiles and percentile ranks.